quite cheaply. Like you can use like you can stream over Wi-Fi, like wirelessly to your PC, and then you can see your screen. But there's a lag, and the frame rate is really choppy and everything, and it just looks awful. And I feel like if I'm gonna force you to, stare at this for 45 minutes in a row, I don't want you to get a headache, So anything I can do to make it go smoothly, I try to do that. So yeah, I think that the capture device was about $200 or something. So definitely not cheap, but I'm very happy with it. Like it does everything that it's supposed to, and I was also very happy that I didn't have to pay for it myself. So okay, I'm just gonna copy the link, put it on the website. Although I have the feeling that most people just sign right into YouTube, and you've probably found my YouTube channel, and my subscriber account has gone quite high, so I imagine that you've probably subscribed so that anytime I start a new video, you just right there, you can't miss it. But anyways, I'll still put the link up because that's what I said I would do. I'll just take 2 seconds. So I realized yesterday I should have assigned a little bit of homework over the weekend, because you already had a lot of homework for the weekend? Okay, well maybe it's good that I didn't then. But in any case, I'm going to assign some today, and I'm going to kind of sort of backtrack on the homework. So the homework for today isn't really going to reflect the stuff that we did today. The homework for today is going to reflect the stuff that we did on Friday. And usually that's not really that big a deal. And I normally wouldn't like make a point of pointing that out. But the topic that we're going to do today is quite a bit different than the topic that we did on Friday. So we're going to be talking about reciprocal functions today. And we're going to talk about reciprocal functions. And yesterday, or on Friday rather, we were talking about absolute value functions and taking like a quadratic function and throwing absolute value bars on either side of it, and then seeing what happens with the graph. So we're going to do something a little different today, but that's okay. Sorry, I have a hard time multitasking here. So, okay, now the video is on the website, so you can click it at your own desires. Okay. All right. Okay, let's get to it. So, a couple things before I get started. Around the end of the class, I'm going to be talking a little bit about our final project. I did some sort of humming and hawing and thinking about your final assessment and what that's going to look like. So I'll talk about that near the end of class. If it's starting to be the end of class and I'm not talking about it, then don't hesitate to interrupt me and remind me that I've got to talk about the final project. But long story short is I'll be posting a document on Google Classroom very shortly. I'm almost finished writing it, but it's just an outline of your expectations and your options and due dates and things like that for the final assessment. So I'll talk about that more in about half an hour. Today what we're going to talk about is this little thing called reciprocal functions. And reciprocal functions, they're interesting because we've pardon me? Oh, my screen isn't on Discord. Oh, thank you. I mean, there's really nothing on my screen right now except my face and what we did yesterday. But thank you for pointing that out, because I totally would have just started a full screen projector. Okay, there we go. And see, I told you I can't multitask. As soon as I start multitasking, I lose track of what I'm doing. Okay, and screen. There's my screen. Go. Okay, you should be able to see me now. Oh, but you can also see my mouse. Can you always see my mouse? Oh no, now my mouse just disappeared. Okay, weird. Anyway. See, it can't multitask. I get so distracted. I'm like a single core CPU. I do not have a dual core processor in here. Just single core, just one thing at a time. Okay, as I was saying, reciprocal functions. So we've already seen a little bit about reciprocals. I want to just remind us what reciprocal means. So what we're going to learn about today is reciprocal functions, but we're going to start off by talking about what reciprocals actually are. So this is what, 7.2, I think? No, 7.4. So this is 7.4 reciprocal functions. Reciprocal functions. Okay, so we're going to talk about reciprocal functions, and we're going to start by talking about what a reciprocal is. So what is a reciprocal? What is a reciprocal? Okay, well, the reciprocal of a fraction is just the fraction upside down. So for a fraction, a over b, the reciprocal is b over a. Okay, so it's just where you flip the fraction upside down. And the essence of reciprocal fractions remains true for reciprocal functions. A reciprocal function is a function that's just sort of been turned upside down. Okay, so a reciprocal function is a function whose numerator and denominator are flipped. Okay, so we're kind of flipping in our reciprocal function upside down. So just to give you an example, to quickly find the reciprocal of the fraction a over b, we can take 1 and divide it by our fraction. Like so. So let's say we want to find the reciprocal of 2 over 7. Okay, if we want to find the reciprocal of 2 over 7, well, here, I'll scroll up just a little bit. So if I want to take the reciprocal of 2 over 7, what I do is I take 1 and I divide by 2 over 7. Okay, so we could also write that fraction kind of like this. It is a little confusing having a fraction within a fraction. It's like a fraction inception. So if you prefer to have brackets around it, that's fine. Usually what I do to just be really clear about which fraction is dividing which, I usually make one of the fractions really big, like the line of the fraction. Like you can see that this fraction line is much bigger. Turns out that it doesn't really matter, but it still kind of helps your brain to say, okay, that's my numerator, that's my denominator. In this case, my denominator is a fraction, right? The fraction 2 over 7. So if you wanted, you could put brackets around it like that. That's fine. But I think that the way I've written it is pretty clear. And if we wanted to get rid of the fraction as a denominator, you'll notice that, well, I could multiply the numerator and the denominator of the big fraction, so like this thing and this thing, I could multiply that by the denominator of the denominator. I know that it sounds kind of weird, but really all I'm doing is I'm taking this 7 and I'm multiplying it in the numerator and the denominator. So the numerator becomes, well, 1 times 7 is 7. And the denominator, here I've got 2/7 times 7. Well, these 7s would cancel, and I get 2. So you can see that I've taken this fraction and I've found its reciprocal by taking 1 and dividing by it. So long story short, I'll just write that. Long story short, if we want to find the reciprocal of something, let's say reciprocal of, let's call it x. If I want to find the reciprocal of x, we take 1 divided by x. Or if we want to, stay with fractions, well, we would do 1 over x. Okay, so that's our long story short. So that's really what we're doing, is we're going to be taking, in this case, not just a value, but we're actually going to be taking a function, a whole function, and we're going to do 1 divided by that function. And that's what a reciprocal function is. So let's talk about that in a little more detail. I thought maybe what we could do is take a function that we know very well, and then we could graph it. We can graph that function, and then we will graph the reciprocal of that function. Okay? So let's start off with an example. So here's our example. So I want to graph y equals x, just a regular run-of-the-mill, nothing weird about it, just a simple function, y equals x, and its reciprocal, which would be, and I'll write this in a different color, y equals 1 over x. Okay, so the y stays the same. We're still graphing y as a function of x. It's the function itself. It's everything that y isn't. Okay, or everything that y is, right? So we keep y to be the same, right? It's still going to be the same y that we're graphing. It's the same y-axis, but it's the x values that we're taking the reciprocal of. So I'm going to take this x and I'll do 1 divided by x, and therein lies the reciprocal. Okay. So let's go ahead with this. So I'm going to start off by, and of course I could do this in Desmos and it would take 2 seconds, but I want to go a little more slowly, and I want to go a little more in depth. So we're going to graph this by hand. Now, when we're finished, we'll go into Desmos and just make sure that we have done everything right, and we can really zoom in on things and make sure that everything looks very precise and accurate. But yeah, we're going to we're going to just do this one by hand. So I'll do it on the little grid paper here. If you have graph paper, I recommend using it. Otherwise, you might just want to make a grid on your loose leaf. But take care with your grid. It is important here that we actually I want to make sure that you take care to ensure that the grid has some level of accuracy, because we do want some precision here. So precision is important, especially when we graph our very first reciprocal function. So this function requires some degree of accuracy. So what I mean by accuracy is that I want you to be able to graph like some decimals or fractions. So usually we kind of have like these, like if we're graphing like a quadratic, we'll have a point at like the origin, and we'll have a point at 1, 1, and then we kind of just focus on the integer values, right? Like 2, 4, 3, 9, and then we kind of connect the dots. With the reciprocal function, I want us to be able to graph like 1 and a half, 1 and a quarter, 1 and an eighth, 1 and a 16th. You know what I mean? Like, we should be able to have some degree of accuracy here. So if you are making your own graph out of loose leaf, I would like you to take some care. If you have a ruler, by all means use a ruler. If you don't have a ruler, use a different pencil, and then use the pencil as a ruler and make a nice straight line. So take a little bit of care while you make your graph, and hopefully in the time that I've spent kind of blabbering away about precision, maybe you've already finished doing your graph. So let's get started. So I'm going to start off by drawing the axes, and I'm actually going to use the geometry tool on my iPad, and we'll keep it kind of centered like this. Okay. And my grid is just a 1-to-1 scale. So this is 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, -3, -4, -5, -6, -7, and 1, 2, 3, 4, 1, 2, 3, 4, 5. I guess it's not perfectly centered, but oops, 1, 2, 3, 4, -1, -2, -3, -4, -5, 1, 2, 3, 4, 5, 6, 7, etc. Negative. You guys get the idea. You've probably done this before. Anyway, okay, now I've got my grid. So I am going to graph the function y equals x, and then we will do the reciprocal. So I'll do y equals x in green, because it's currently in green when I wrote the function out. So these are all the points where x and y are equal. So that would be 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, -1, -1, -2, -2, etc., etc. And then we will connect these with a nice straight line. And I'll try to make it as straight as possible for the geometry thing to autocorrect. Didn't do the best job of autocorrecting. It's a little bit lumpy over here, but whatever. It's straight enough. And okay, there's my function, y equals x. And I'll go ahead and just point at it, say that this is y equals x. Okay, now we're ready for the reciprocal function. The reciprocal function. So we are going to graph the reciprocal of x, or in other words, we're going to graph y equals 1 over x, or 1 divided by x. So let's go ahead and start graphing some points. So one thing that you might notice here is that we have a non-permissible value. X cannot be equal to 0. X cannot be equal to 0. So we do a special thing. We graph what we call a asymptote. And I'll spell that out for you shortly, and I'll make this a little bit thicker. So at the line x equals 0, so these are all the points where x is equal to 0, we make a red dotted line like so. And I'm going to get rid of the pink stuff. It's kind of bugging me. So yeah, we don't need all this. It's just hard for the eyes. A lot of it. We know it's a 1-to-1 scale. Okay, and I'll do that as well. Beauty. Okay, we know it's a 1-to-1 scale, so I'm just going to remove that because it's easier on the eyes if you can just see this. So yeah, we write this little dotted line, and then just to indicate the precision of this, right? To say, okay, well, to indicate that there is an asymptote where it is. You know, sometimes with a graph, your graph isn't perfectly precise. So we do want to actually tell the other person who's reading the graph what this is. You could say asymptote at x equals 0. Okay, so that's how you spell asymptote. There's a P in it. And we write that there's an asymptote at x equals 0, and an asymptote is a value that our function gets very close to but never equal to. So we'll see what that means in a minute, but I thought that I would just start off by saying, hey, let's point out right away, like the elephant in the room, x can't be 0, right? That might be the first value that you try out, right? It was the first value that, I'm pretty sure it was the first value that we tried with the function y equals x, right? We started off with 0, 0, right? We said, okay, if x is equal to 0, what's y? Well, obviously y would have to be 0 too, because they're equal. In this case, what we're starting with is, okay, what if x is 0? Doesn't really work, right? Y equals 1 over 0. We get an asymptote, okay? Are there any questions so far? Have you guys ever heard of asymptotes before? How are we doing with that? Yes. Yes. Yeah. So the question was, if we're graphing the reciprocal of a function, will the asymptotes of the reciprocal function correspond to the x-intercepts of the original function? And the answer is yes. So anytime our original function, like the function that we just drew in green, like this function right here, okay, anytime our original function passes the x-intercept, or sorry, passes the x-axis, which would correspond to an x-intercept, all of those would correspond to a vertical asymptote, because that would be the point where we would be expected to divide by 0, right? And you can't divide by 0, so We have a vertical asymptote. Okay. Okay, so this is our vertical asymptote. Now what we have to do is we have to start graphing some other functions. So graphing some other points. So let's just start off by looking at this side of the function. And what we're going to do is we're going to take a value like right here, and then take the reciprocal of this value, which is 1, and then see what we get. Well, let's do this in purple. Okay, I'm going to choose purple. Where did my purple go? There's purple. Okay, so at this value right here, when x is equal to 1, okay, I'm going to leave that up. So when x is equal to 1, 1 over x is, well, 1 over 1. So we would actually get a point right here. So both the function and its reciprocal share a point right there at 1, 1. Okay, let's see where the next point is. Like, where does this one belong? So when x equals 2, what is 1 over x? What's 1 over x? Well, when x equals 2, 1 over x would be 1 over 2, or a half. So there we go, we have a half now. Okay. What about this next point here? So when x is equal to 3, well, we'll have 1 over 3, which is a third. Okay. After a third, you can probably see the pattern here. We've got a quarter, and then a fifth, and a sixth, and a seventh, etc. So we have these fractions with an increasing denominator. The denominator is increasing by 1 each time. Okay. Now, so you can kind of see what's happening here, and I'm going to sort of try to approximate this best I can with a line. Okay. Now, you might start to wonder, okay, well, what's happening over here? Like where do we end up going? Like, do we just kind of hit it at some point, and then, okay, but we go close, but because we can't actually equal 0. Let's see what happens as we get closer and closer to the asymptote. So what I'm going to do is I'm going to choose a point right over here that's about halfway between where we are here and where we are here. So let's think about, okay, what happens when x is equal to a half? Okay, what happens when x is equal to a half? So if x equals 1/2, 1 over x is equal to, well, remember, we're thinking about the reciprocal, right? We're flipping that fraction upside down. So, I mean, if we wanted to really stick with algebra, then we would say, oh, that's 1 over 1/2. That's equal to, well, that's equal to 2, right? That's what the whole reciprocal means. We're flipping these fractions upside down, right? We're taking a value and flipping the numerator and the denominator. So the 1/2 now becomes 2. So there we have it. So I'll try to make that a little more precise. So we get a point right here. How about, well, 1/3? How about, what if we looked at 1/3? So a third is right around here. When x equals a third, 1 over x would be 3 over 1. So we would get a point here. And then at x equals a quarter, we would have the point 4. And when x equals a fifth, we'd be at 5 there. And you can kind of see, you get almost like a little mirror image that's happening on this side. So there's our graph, or the first part of our graph. And yeah, so there it is. So it's kind of a nice looking graph. I think it looks pretty cool, actually. And then to signify that this keeps on going, we are going to put an arrow on either end. That's important as well, because that tells us that this graph keeps on going and going on and on forever. So you can kind of see what's happening here is that we're getting arbitrarily close to our asymptote. And what I mean by arbitrarily close is I mean that we can get as close as you would ever want to be. So you can give me any value, any positive value, and we will get that close, right? So you could say, okay, well, is the graph going to be within 0.001 units of the asymptote? The answer is yes. So any positive value, like a non-zero positive value, anything that represents any kind of length. If you ask, will the graph be that close to the asymptote, the answer is yes. That's what it means when I say the graph gets arbitrarily close. Okay, so it gets arbitrarily close to the asymptote. Okay, the same could be said about the x-axis, right? The graph comes very close to the x-axis, right? But it never gets equal to it, right? Because we're talking about, again, reciprocals, right? So if this actually went to 0, then the reciprocal of this, like the green function, would have to be 1 divided by 0. So in the same reason, for the same reason as it gets close to the vertical asymptote, we also see that it gets arbitrarily close to the horizontal asymptote, y equals 0. So we actually have another asymptote to mark. We have the horizontal asymptote. So this horizontal asymptote is along the x-axis. So we have two asymptotes to be concerned with. This is the asymptote at y equals 0. Okay, so along the x-axis. And later, I don't believe it's part of this course, but I think next year you will look at some functions that have asymptotes that are diagonal lines, and those are pretty neat too. But for now, we're just looking at a vertical asymptote and a horizontal asymptote. So the asymptote isn't always just so much like a value that you cannot be equal to. It's more or less like this is a value that you can get arbitrarily close to, and that's what an asymptote is. When I was in pre-calculus as a high school student, I always thought of asymptotes as like red tape that you're not allowed to cross. Like, oh, you're not allowed to be here. And in some ways, that's what it does mean. But in some cases, you actually can be at your asymptote. And I'll show you an example of a function that has a horizontal asymptote that it actually does eventually equal. So again, this isn't really a function that we would look at in this class, but maybe you can imagine it. So imagine we had some kind of wavy function like this that's kind of going up and down, but then as it progresses, it gets closer and closer and closer to just being a straight line. Well, you could think of this as having an asymptote at x equals 0. Or sorry, y equals 0 there. Or another one too, if you wanted. This one may be a little more easier to imagine. Just like something that kind of has a bit of a wave like this, and then whoosh, kind of goes off and gets arbitrary. Like after this point, like maybe this function crosses the x-axis twice, but only twice. And after this little bit, it goes very, very close to the horizontal asymptote, but never touches it. So you can imagine situations like that. So it's not that the asymptote is like a red line that you can never cross and you can never be equal to that value. It just means that our function is going to get arbitrarily close to this value, but never actually reach. But maybe it's reached at some point before. Like it's kind of talking about like, okay, so I've got this arrowhead here, right? Where's that arrow headed? Like where am I going off to? Like as this function goes on and on and on and on forever, like where is it pointing? And then that's what the asymptotes are for. So we've got a vertical asymptote, a horizontal asymptote, and now we just have to graph the left-hand portion of the graph, because we haven't looked at what happens when x is negative, but it's actually not that different than what's happening when x is positive. So we'll just sort of quickly go through it in the same fashion that we did before. So if x is equal to -1, so right over here, when x is equal to -1, well, what's 1 over -1? Well, -1. So, oops, this should be purple. So here we go. Oops, that's not purple. That's purple. Okay, so I've got -1, -1. Okay, and let's go a little bit further to the left. So if x is equal to -2, I've got -1/2, right? And then when x is equal to -3, I've got 1 over -3, or -1/3, and then -1/4, -1/5, -1/6. And in the same way, we have the same kind of mirror image happening over here. Okay, so there's a lot of symmetry to this, and we can really exploit that symmetry to make our life a little bit easier. And I'm going to do my best job to smoothly connect the dots. And there we have it. Somehow I kind of find this like a little bit relaxing, kind of like if you are doing like a coloring book or something, kind of like I wonder if you've ever played the game Picross. I think that's what it's called. Picross. Has anyone heard of that game? No? Picross? I think that's what it's called. Picross. Okay, yeah, Picross, which is basically just like a nanogram, according to Wikipedia. You should really check them out. It's kind of like Sudoku, except you draw a picture. I'll maybe at the end of class, after I talk about your final project, which I have to do in just a couple of minutes, maybe I'll tell you a little more about what Picross is. But Picross is kind of doing this sort of thing, reminds me of Picross. Like you could just have these little tidbits of information, and you're kind of just thinking, okay, well, this 1 has to go to 1, this -2 has to go to -1/2, and you kind of just connect the dots, and before you know it, you're left with this beautiful picture. So yeah, there's like squares with numbers, and yeah, so I used to have it on my 3DS, my Nintendo 3DS, and yeah, basically what they would, and I think there's a few different versions of it. Yeah, I guess nanograms, also known as Picross, Griddlers, or Pick-a-Picks. Very other names. It's a logic puzzle. But yeah, how does that work again? Like it'll tell you, yeah, like you have groups of colored dots or something. So you have this big array, like a grid, kind of like this, kind of like what the background of my screen is, just a big grid. And then it'll tell you certain numbers along each, like the very title, like at the top, it'll tell you a whole bunch of numbers, and then a bunch of numbers on there, and it corresponds to how many like dots you have in each column and then in each row. So then you kind of have to sort of guess where the dots go. So you're like, okay, well, if this column has like 3 dots, and then this row has 2 dots, and there must be a dot either here or here, and you kind of go through this logic. And you start filling it in, and then as you fill it in, it gets easier because there's fewer decisions for you to make. And then before you know it, you like have this really cool like pixelated drawing of something interesting. Like it was the version that I had was for Nintendo, so it was like a picture of Mario or something like that. But it was really satisfying because you just would be looking at these tiny little things, doing one thing at a time, and then you kind of take a step back and you're like, oh wow, look at this cool thing that I just created. So that's kind of how I feel like reciprocal functions are. It's like they look really complicated at first, and you think, oh my gosh, like if I was just like, oh, okay, yeah, so we've got these reciprocal functions, they've got like a vertical asymptote, a horizontal asymptote, and just showed you a quick little thing on algebra, how to calculate it, and then you have this shape, and then you have this shape, and then we moved on, you'd be like, well, that's not really interesting, it's not beautiful, it just looks kind of scary. But if you just break it down and kind of take it one step at a time, and then take a step back and realize, hey, this is really pretty, then maybe you'll have a better appreciation for it. So yeah, that's about as far as I'm gonna go with reciprocal functions today. We'll pick up where we left off tomorrow. There's a lot more to talk about. Like we're just scratching the surface here. But I think this should hopefully give you an idea of sort of what we're doing and how to generate these things. I also don't want to go too far into it because I still have to assign homework from Friday's materials. So yeah, let's talk a little bit about homework, and then I'll do the final exam, and then maybe we'll do like a Picross together or something. Okay, so absolute value equation 7.3. I would like you to do, so homework for today. Homework is, okay, 7.3, which is it starts on page 389. Page 389 and ends on page like 391. 391. Okay, I want you to do questions 4 and 5. Questions 4 and 5, all of them. 4, 5, and 6 actually. I'm gonna go 4 to 6. 4 to 6. 4 to 6. And I know that's like 15 questions already, so I'll go easy on you for the rest of it. We'll do number 9. Number 9. Question 9 and oh, I like these kinds of questions. 15. Okay. Question 15. So 4 to 6, all of them, and then question 9 and question 15. Okay. So that's your homework for today. Sorry, I guess I'm not sure why I didn't assign it on Friday. Maybe because maybe I think we called it quits early on Friday. Maybe I forgot to give you homework. Anyways, sounds like you had a lot of homework to do over the weekend anyway, so maybe you wouldn't have even done it to begin with. So yeah, there's your homework for tonight. Okay, so for the final assessment, and I guess I'll make the exit slip just about the final assessment. So your exit slip for today is comment on the final assessment. Okay, so just share your thoughts with me here. So I did some thinking over the weekend, and I decided just to make things as simple as possible. And maybe this isn't super simple, but it seems simple in my head. At least from my perspective, it's simple if all my classes are doing the same thing. It's much less for me to sort of micromanage. So what I'm going to do is I'm going to do the same thing in all my classes, which is I'm going to provide an option for you to do either a final exam, just like a traditional final exam. The content of the final exam would be approximately what you could expect from a normal final exam, which would be, about 3 hours worth of work. So you would have 3 hours to do your work, but then to give you a little bit of extra time to, scan your work, upload your documents, etc., etc., I'll give you an extra 2 hours. So this would be a 5-hour time frame. So the way it would work is that at 9 a.m., 9 o'clock in the morning, you would have access to your final exam. You could either print it out, or you could look at it on your computer screen and then just write your work on a piece of paper. And then 5 hours later, which would be at around 2 p.m., that would be when the window to submit your work would close. And I'm afraid to say that it would be like a hard deadline. Like I would not be accepting any late material. It would kind of be like in a final exam, it's like 3:30 rings, like I'm sorry, you got to go. Like we can't have late submissions for a final exam. So that's what the final exam would look like. It would be administered through Google Classroom, and I put a few notes in this document that I'll release. Hopefully I'll release it today or tomorrow. A few just notices about things regarding extensions and late submissions and things like that. Just some of the policies that I've kind of set up, and some ground rules, just so that day of there's no misunderstandings. Because with this sort of thing, like we can't have like a late submission. There's just not enough time, because it takes a tremendous amount of time and work to mark which is something that I think students often forget, that marking is extremely time consuming and extremely taxing. So it's at the end of the year, and then we have a report card to write as well. So so there's just not enough time for flexibility with times and dates. So the final exam would be at a very specific time. I would not accept late submissions, but you can think of it as 3 hours of doing the actual exam, and then 2 hours to scan your work and upload it and make sure that there's no sort of technical difficulties. And during that time, if you needed help with scanning or uploading or anything like that, then you could contact me. Another point as well is that I will only be accepting PDFs. I cannot accept JPEGs any longer. The JPEGs is just, it's nearly impossible to incorporate that into a workflow that makes any sense. So I would require PDFs. So if you want to do the final exam, that is what the expectation is. So I'm not sure how many people want to do a final exam. I know that some people didn't really seem that interested. Some people did. Some entire classes seemed a lot more interested in the final exam than other classes. So it seems to all sort of depend on many variables. So that's what the final exam would look like. 5-hour affair. It would start at 9 o'clock a.m. It would be a hard deadline at 2 p.m., etc., etc. So so that's the final exam. The other option is let me just pull up my PDF here. I was just working on it. Here it is. Yeah, the other option would be a project. So the project there's a lot more flexibility with the project. Just to get a couple things out of the way, an extension may be granted if you ask ahead of time. So if you know ahead of time that you absolutely need an exception for an extension, you need to let me know ahead of time. I will not be granting extensions after the due date. So once the due date has happened, if I haven't heard from you, anything that would be submitted to me would be considered late, and late projects, I cannot accept late projects in this case. So yeah, unless there's like a very a compassionate circumstance, like a death in the family, or even if it's related to COVID, like something related with your home life, just it's not working, and you were just unable to contact me ahead of time for an extension because of a very specific compassionate reason, then I can't make any exceptions for the same reason as with the final exam. Like, there's just literally not enough time to mark final exams and projects in all 4 of my classes, and then also write report cards and have that all done by the time that the report cards are due. So unfortunately, there will be no exceptions for deadlines, which means that if you're like 70% finished your project, just send it unfinished, because it's better than nothing, right? So yeah, that's just the expectation right off the bat for the final project. So for the project, I've kind of, again, I'll give you a document that explains all this in great detail, but there's 3 things I need you to make very clear of when you choose your project. The first one is form. So like, what form will your project be? Are you going to make like a video? Are you going to write a paper or an article or something like that? Are you going to do a presentation to the rest of the class or something? Are you going to like live stream like I do? There's a lot of different forms for you to choose from, and I'm pretty flexible. Just the requirements would be that you'd have to be able to do it online, so you'd have to be able to submit it in some way or another. So I think that the most straightforward project would be an article, right? You could just use Google Docs and then submit it to me when you're finished. So that's the first thing you need to figure out, is the form. The second part is the content. So what are you going to talk about? Like, so the content should be something, a topic that we learned in class. So maybe it could be quadratics, maybe it could be, I don't know, reciprocal functions like we learned about today. You could also do several topics and talk about the connections between them, and that kind of thing. So I would encourage you to do more than one topic. I haven't completed making a rubric, but I reckon that if you just do one topic, then I may not give you full marks. The way I'm sort of picturing this is that since it's a replacement for a final exam, and a final exam actually does cover the full, curriculum for that year, I'm inclined to think that we should be covering many topics. So I mean, like I said, I haven't quite finished this document, so I'll submit it either today or tomorrow. But the gist of it is that you have to choose some content from the class, whether it's one major unit or several units. I'll have to think about. So that's the two things so far: form, content. The last thing is scope. So scope refers to like how much you are thinking about, like all the different topics that you're going to choose, and then also in what level of detail you're going to talk about those topics. So it's like the breadth and the depth of your topics. So like how are you going to portray these topics that you've chosen? Are you going to just do some examples, like a worked example, kind of like my notes? Are you going to talk about the real world and talk about how these topics can be applied in the real world, that kind of thing? So you have to think about that. And it's a really good idea to do this ahead of time. So the scope should really be the first thing that you decide on. Form and, well, I guess it should be content and scope should be the thing that you think about first. The form that you decide should be the last thing you choose. It tends to be the first thing. People say, oh, I want to do a video. It's like, okay, great. A video about what? Right? And then, oh, okay, well, I haven't thought about that yet. Well, think about the content and think about the scope first. The scope especially is really important to get down because you really don't want to overwhelm yourself. Like, I don't want you to think, okay, what's this, like, what are you doing? Like, okay, well, I'm going to do the math that we learned in grade 11. It's like, well, we learned a lot of math. Which math, right? In what level of detail are you going to be talking about this stuff, right? So those are the three things that you need to recognize. Now, again, this is in the document, which I'll release very shortly. In the document, I mentioned that I also want you to include a little blurb about the form, content, and scope. So I want that to be explicit, and I no matter what form you do, like if you do a video or if you do something else, I need you to submit a little document alongside your final project that tells me what the form, the content, and the scope is, for you to tell me that you've thought of this, that you actually have planned this. So that's what I require for the project. I know I've gone over by about 8 minutes now. There's 2 more things I want to talk about though, so just bear with me. So those are your choices, the final exam or a project. That will be worth 75% of your final assessment. So that could, I think that for this class, our final exam is worth 30%. So this would be 75% of that 30%, okay? The other 25% is something else that you don't get a choice on. And I was going to do this regardless, like before the COVID thing, and this is just something that I want everybody to do in all of my classes. And I want you to make a topic map. Okay, so that's, everybody is going to do a topic map, and that's worth 25% of your final assessment. So for this class, that's 30%, so it'd be 25% of the 30%. So it's about 7.5% of your final grade. Okay, so the topic map, what I mean by that is I want you to list a minimum of 10 different topics that we covered throughout the year. Okay, so they could be a big topic or a small topic or anything like that, and I want you to sort of make this nice little map with all of these different topics and a short little description about what each of those topics is. And then I want you to make a connection between all of the things that have connections. So if two topics have a connection, if they're connected somehow, then I want you to connect them with a line. And on that line, I want you to write what the connection is. And in the document, I give you an example of two topics that have some relationships. So the ones that I chose were trigonometry, and then the little description is it's got SOHCAHTOA and it works with right angles, right angle triangles. I know that we haven't done trigonometry yet. That's next on our list, but you get the idea. So one of the topics could be trigonometry. Another one could be the Pythagorean theorem. And then I wrote, a squared plus b squared equals c squared. I also wrote c equals the square root of a squared plus b squared. And then the connection was right angle triangles. So they both deal with right angle triangles. So those would be two topics that are related. So I would require a minimum of 10 different topics that we've learned throughout the year. Connections between them, little descriptions of what each one of those topics are. And for this, you can work in with a group or a partner, by yourself. It's all fine. I'm not really concerned about cheating. There's no cheating here, but I do require you to submit your own work. So we can't just have a group of 12 students collaborating, but we're all handing in just the master copy that is all of our work. No, you actually have to draw it yourself, scan it, upload it, right? It has to be your own penmanship. You actually have to write it yourself. But if you want to work with a big group, that's fine as well. But it does have to be your own writing. So that is worth 1/4 of your final assessment. So everybody, regardless of your choice, will have a Part A and a Part B. Part A is a topic map. Part B is the final exam or project. Okay, and then within the final exam, the project. Again, I already talked about that. There's lots to say. Now, one more thing. I said I had 2 more things to talk about. That was the first one. The last thing I want to talk about is your final grade. And again, I wrote this out in this document. And I want to be really transparent about this. I don't want any surprises to come up. I think that we all know that your final grade has a minimum, right? And we know that minimum corresponds to what your grade was on March 23rd, 2020. Okay, that's so. As far as I understand, and from what I've been told, and I've checked this several dozens of times, but the minimum grade that I am allowed to give you is what your grade was on March 23rd of 2020. So that has there's a lot, I think there's a lot of good reasons for that. Because, this obviously is a huge disruption to people, and not everyone has equal access to technology, and it doesn't make sense to penalize some people because of their circumstances, right? So I understand that. But then, of course, it obviously raises the immediate red flag. Well, what is encouraging students to hand stuff in, right? Why would students participate? If you got a 95 by March 23rd, why even bother handing anything in? You already got your 95. You can start your summer early. Well, so we have been asked to document, if students are handing in assignments and things like that and are participating in distance learning. And so according to our professional judgment, oops, what did I do there? Oh, okay. Oh, my iPad turned off. Oh, I see. Okay, oops. So according to our professional judgment, we'll be asked on the final exam to report whether or not the student has participated in the remote learning between March 23rd and the last day of school. And based on that assessment, we'll be asked whether or not we think that that student will require what's called recovery learning. So recovery learning, as far as I understand, is a new initiative led by the government of Manitoba, which addresses students' needs for sort of recovery work for the next year due to this whole COVID-19 thing. So if you've really sort of struggled and the reason you struggled was because of COVID, then you may be asked to participate in recovery learning for next year. So I put a link on recovery learning. You can look it up on Google for in the meantime. Just look up recovery learning, and there's just look at make sure you look at like the government of Manitoba's website, not like, I think there's some news. The first result in Google for me was like CTV doing a video about it. I wouldn't really listen. I mean, I have nothing against CTV, but why not just see what the government has to say, because that's actually what matters. So look for the government of Manitoba's website on recovery learning. Maybe that it applies to you, maybe it doesn't. And chances are, if you're not watching this video at all, then it probably does apply to you. Yeah, so it's not like you can still pass this class, but be required to do recovery learning. So I'd highly recommend reading that. So take a look at that, and I'll post this information on Google Classroom either today or tomorrow. So does anyone have any questions about that? I know that was a lot of information that I just sort of dumped on you. No, are we good? Okay, cool. Great. So yeah, I'm gonna sign out then. So yeah, the exit slip is just a comment on the final assessment. If anything seems alarming, or if it seems fun, or if you're totally fine with it, you don't really care, just let me know. And then I'll read those comments, and I'll take them with a I'll try to incorporate those ideas into the final exam. But I've pretty much decided what we're doing, which is just you get to choose if you want to do a project or a traditional final exam. So I'm gonna go. I'll talk to you guys tomorrow, and have a good rest of your day. Bye bye.